Here is a statistics question on chi-squared goodness of fit, customer satisfaction. How do I know I can do goodness of fit? I have to have multiple categories, which I have, very satisfied, satisfied, and dissatisfied. I have to be able to come up with numbers, counts. The counts have to be greater than 5. So I'll check that in a moment. And I have to have a random sample. Well, this is a random sample. All right, so notice these are counts. These are the random survey found. These are the observed values. These are going to be up here, the expected values, and I have to turn them into counts. And then I want to make sure all those counts are greater than 5. So this is 30%. The survey was 400 customers. So the expectation would be 0.3. 30% is 0.3 times 400, which you can do that on a calculator. Comes out to 120. This one is 0.5, 50%. The retailer expects that 50% of these 400 would be satisfied. That would be 200. And the retailer expects 20% would be dissatisfied, which would be 80. Do those on a calculator. So those are the expected numbers. Those are the observed numbers. And notice all of these are greater than 5. Yes, yes, yes. So I'm good. I can use a chi-squared goodness of fit. I can either calculate this by hand, or I can use the calculator to find all the values. I'll do both. Defining the question and hypothesis. It says at a significance level of 0.05, test whether the customer satisfaction distribution matches the retailer's claim using the 4-step process. Well, step 1, define it. The null hypothesis is at A is 0.05, matches. The alternative hypothesis, as at a significance level of 0.05, does not match. The distribution, the customer satisfaction distribution, does not match the retailer's claim. Okay, and setting the standards for decision making, I'm going to compare these. Whatever the p-value I find, I'm going to compare to 0.05. If the p-value is greater than 0.05, I will fail to reject. If the p-value is less than 0.05, I will reject the null hypothesis. I will reject the hypothesis that the distribution matches the retailer's claim. If p is greater than 0.05, I will fail to reject the hypothesis that it matches the retailer's claim. There will be no concluding evidence that it does not match. Okay, so what else do I need here? I know that I need degrees of freedom. Degrees of freedom is going to be k, the number of categories, minus 1. There are 3 categories. Very satisfied, satisfied, dissatisfied, minus 1. Degrees of freedom is 2. I may need to do that. Now, I can calculate the chi-squared value, or I can put a table, put all these values in a table, and then let the calculator spit everything out, including the chi-squared value and the p. First, I will do it the easy way. Let the calculator spit it out. So I want to take these values. These are the expected values, 120, 280, and the observed values, 120, 210, 70, and enter them into the calculator. So I'm going to clear this. I'm going to go to Stat and Edit. Bam. And then I've already entered them. I just did this question. And so 120, 210, I can enter them either one. It doesn't matter whether I put in an L1, L2, L3. I just have to make sure I know which one I place them in. So 120, 210, 70, 120, 210, 70, that's the observed. That went in L1. 120, 280 went in L2. The expected is L2. Have to know that. So now I'm going to go to Stat and Tests and go down to the chi-square goodness of fit tests. I can't remember what that meant. And I press enter. And I think I've already got them in here. Observed is L1. I will verify that. Yes. Expected is L2. Yes. Degrees of freedom. 3 minus 1 is 2. Yes. And then I don't care what color it is. I'm going to calculate. And I got a chi-squared of 1.75. Not really important right now. The most important thing for me is the p-value, which is 0.417. Well, guess what? That's greater than 0.05. So since it's greater than 0.05, I will fail to reject the null hypothesis. There is not convincing evidence that the distribution is, this is the alternative hypothesis, not convincing evidence of the alternative hypothesis, which is that the distribution does not match the retailer's expectation. Okay, so I failed to reject the null hypothesis. All right, I will show you how to do it the long way. To do it the long way, I have to calculate the chi-squared value, which is the summation of the observed minus the expected squared divided expected. In other words, for each category, I find that value and I add them all together. So for the first one, the observed is 120, very satisfied. The expected is 120. So it's going to be 120 minus 120 squared divided by 120. Guess what? That's going to come out to 0. Why do I have this big blob there? I don't know. I don't know what that thing is supposed to be. Why don't I get rid of it? Some kind of a symbol or thing that was on the picture. I guess I'm going to put 120 back down here. 1, 2, 0. Aha. Okay, now I will do the second one. Observe, this is satisfied. 210 minus 200 squared. Well, that's just, well, I'll just put it 210 minus 200 squared divided by the expected value, which is 200. And now I'm going to need more room. I'll get more room. Plus, then I want the third category, dissatisfied. Observed, 70 minus expected 80 squared. 70 minus 80 squared divided by expected, which I believe is 80. Let me just double check it. Expected is 80. So let me calculate these. This is 0. This is 210 minus 200 is 10 squared is 100. Over 200 is 0.5. Plus 70 minus 80 is negative 10 squared is 100. 100 divided by 80 is 10 over 8, or 5 over 4, which is 1.25. And that comes up to 1.75. That's the chi-squared value, 1.75. And it matches what that other thing spit out, matches it. So now I can take that 1.75 and put it into a different function on the calculator. I'm going to do second vars. Whoops, what happened? Second vars. Clear. Okay, let me reload this because it's not cooperating for some reason. Second vars, there we go. And I go down to chi-squared CDF, x squared CDF, boom. And I put my lower value, which is my chi-squared value, 1.75. My upper value, which would be a very large number, I'll put 1e99. 1 times 10 to the 99th power, degrees of freedom. Number of categories is 3, minus 1 equals 2. That's how you calculate degrees of freedom. Number of categories, for some reason, a lot of times it's called K, minus 1. There's 3 categories, minus 1 is 2, so I'll put that there. And then I go down to paste and then enter it, and it comes out with the same value. P equals approximately 0.417, which is greater than the significance level of 0.05. I failed to reject the null hypothesis. There's not convincing evidence that the distribution does not match the retailer's expectation. In other words, not convincing evidence of the alternative hypothesis. So whether I calculated chi-squared by hand or let the calculator do all the work, the answer came out exactly the same.